Okay, so in this video we're going to go over worksheet 1 from the solutions homework, and I'm going to start on number 4. You see your equation there on number 4, and it says aluminum carbonate plus nitric acid yields aluminum nitrate plus water plus carbon dioxide. First thing we need to do is balance this thing, and when we do balance it we get this. Aluminum carbonate, solid. That's a pretty important piece here. Plus nitric acid. There's 6 of those. Oops, sorry. Let me erase that real quickly here. HNO3, and that's aqueous, yields 2 aluminum nitrates. And that's aqueous, plus water, liquid, and finally carbon dioxide, and that's a gas. So that's our balanced equation there, and I'm sorry about my handwriting, it's pretty awful anyway, and it's even worse on here. But once we get that, we can really split this thing up into the different ions. I'm going to change colors here for us to do that. Let's go pink here. When we split this thing up into ions, we don't want to split up the solid stuff because that's not going to ionize when we get it in solution. So we're going to have aluminum carbonate still, and that's still going to be solid. We are going to split up the aqueous stuff. So we're going to have 6 H pluses, and those are still going to be aqueous. And then we're also going to have 6 NO3s, and they're also going to be aqueous. And those are a -1 charge. Once we get that, we can move on to our products, and I'm going to give us a long kind of curvy line here. When we split up the aluminum nitrate, we're going to get 2 aluminums, and they're going to have a +3 charge, and those are aqueous, plus 6 nitrates, aqueous, and those are a -1 charge still. And then we're going to get 3 waters. We don't split this up, that's still a liquid. And we get 3 carbon dioxides. We don't split those up either because those are a gas. Once we get that, we can kind of cut out the fat. We can get rid of the stuff that's extra. So I'm going to switch to a black marker so we can look at that. We don't have this in our products, so that's going to stay. We don't have this in our products, so that's going to stay. Our nitrates, though, we have on both sides, and I tried to outline those in a dotted line for you there. We've got it on both sides of the equation, so really we don't need it on either side of the equation. Everything else here, the aluminum, the water, the carbon dioxide, is going to stay. So when we write our net ionic equation then, and I'm going to do that in blue for us, when we write our net ionic equation, we're going to have aluminum carbonate, and that's still a solid, plus 6H plus aqueous goes to 2 aluminums, aqueous, and those are +3, plus 3 waters, plus 3 carbon dioxides. And that is your net ionic equation for number 4. I'm going to go ahead and erase that so we can move on to number 6. On number 6 we have magnesium bromide plus potassium hydroxide yielding potassium bromide plus magnesium hydroxide. This is a classic double replacement reaction. I'm going to write the balanced equation up here just like I did last time so that we can get started on this. We're going to have MgBr2, and that's aqueous. I'm going to quit writing the parentheses, I think, just for the sake of handwriting, plus 2 KOH, and that's also aqueous. And never mind, I'll keep. Okay, the next thing we'll add here is the 2 KBr, and that is also aqueous. Sorry, I forgot to, that should be an arrow there. And then the last thing we need in our balanced equation here is the magnesium hydroxide. And I'm going to run out of space here, but bear with me. Magnesium hydroxide 2, and that is a solid. Okay, now we're ready to break this up into ions, and we'll do this just real quickly here. The magnesium bromide is aqueous, so I'm going to change colors for us here. And we're going to have Mg plus 2, and that's aqueous. Plus we've got 2 Brs, and those are both -1. Those are aqueous. Plus the 2 KOH, so we're going to have 2 potassiums. Those are +1, aqueous. Make that a Q there, or try to. And then plus the OH minus. And again, that's aqueous. Hopefully you're noticing a trend here. And then we're going to draw a long arrow here to the 2 KBr. So we'll have 2 Ks plus 1, aqueous, plus 2 Br, -1, aqueous. And then our precipitate here is going to be the magnesium hydroxide, so we'll add just that MgOH2, and that is a solid. Okay, we know what our precipitate is. Now we're ready to kind of trim the fat, as Josh Frost said in the second hour. So some of the fat that we have here are the bromines and then also the potassiums. So this bromine is here. It's also here, so we're going to X those. The other thing that we can cross off here is the potassium, and we'll outline those just so you know where they're at, and we'll cross those off because we really don't need either one of them. So I'm going to slide us down here. Then our net ionic equation, the stuff that's left over after we trim off the extras, is going to be Mg, and that is aqueous, with a charge of +2, plus OH -1, and I think there should actually be 2 of those. I could be wrong. Yeah, there should be 2 of those. So that should be a 2 there, and that should be a 2 there. I screwed that up. I apologize. Plus 2 OH -1, and that's aqueous as well. And then that reacts to form magnesium hydroxide, and that is a solid. That is your net ion. Okay, I'll go ahead and erase this, and we'll move on to the next one. That's number 8. This one's really not too tough here. We've got 2 potassiums, and those are both solid, plus 2 waters, and that's a liquid. Sorry about my L there. Going to 2 KOH, and that's aqueous, plus H2, and that's a gas. Okay, now that we've got our balanced equation here, we need to split this thing up into ions. The K solid, or the potassium solid, we really don't split up into ions. We've just still got 2 potassiums, and they're solid. The water, we also, and then we've got those two waters, and that's a liquid, so we're not going to split that up either, so we don't have any ions yet, really. The 2 KOH we can split up into ions, and we'll say there's 2 K plus 1, and those are both aqueous, and then 2 OH minuses, or -1, excuse me, and those are both aqueous. And then the H plus we're not going to split up either, so we're just going to have, or H2, excuse me, H2 gas. Now, there's nothing here that we can cancel out. There's no fat that we need to trim off, so we have our net ionic equation. That's it. So that's pretty sweet. That's a nice one there. I'm just going to move us down, so I hope that you can get that copied and kind of move on here. For our next one, this is our last one. This is number 10. And I'm going to go ahead and put our balanced equation up here. We've got 2 aluminum, and that's a solid, plus 6 HCl, and that's aqueous. And that reacts to form 2 aluminum chlorides, and that is aqueous, plus 3 hydrogen gas, or 3H2, and that is a gas. This one, if we go ahead and split that up into ions, and we're going to go ahead and do that here, we don't split up the aluminum solid, so we're just going to have 2Al solid. We can split up the hydrochloric acid, that HCl, so we're going to have 6 H pluses, those are aqueous, plus 6 Cl minuses, I want to put the plus 1 up there, those are also aqueous. And that goes to, we can split up the aluminum chloride, so we'll have 2Al plus 3 AQ, or aqueous, plus 6 Cl minus 1 aqueous, plus 3 H2 gas. Can't split that up because it's a gas, it's not aqueous. If we trim the fat off here, there's really not a whole lot of fat that we can trim. Our aluminums we can't really trim because we go from a solid to an ion. Our chlorines, however, we have on both sides, so those can disappear. If we write down our balanced equation now with just the stuff that we have left over, or our net ionic equation, we're going to have 2 aluminums solid plus 6 hydrogens, and that's plus 1 in aqueous, reacting to form 2 aluminums with a 3 plus charge in solution, plus 3 H2s, and that's a gas. Hopefully that helped you out with the worksheet number 1 homework. I will talk to you later.